Okay, going to work through the final exam review for Chapter 2 in Algebra 2. I'll put a link to the worksheet in the note-taking guide. Okay, so starting off with factoring some trinomials, I'm going to use a diamond problem here. Set up a little x thing, and I'm going to put the coefficient of the x term, the b, is going to go up here, and then the c, that's the constant, is going to go down here. Now I'm looking for two numbers that are going to add to -8. The same two numbers multiply to 7. So if you think about ways to multiply to get 7, you got 1 times 7 or -1 times -7. Those are the only two options. This is the winning combo. So that's the numbers I'm going to put on the left and the right of my diamond. And you could switch the order of them. It doesn't matter what order. But what that does is it tells you what goes in the back of these parentheses. So I should have a -1 and a -7. And there's my answer. And you could try multiplying it together. You could FOIL it, and you should end up with the trinomial you started with. Okay, on number 2, I've got, whenever you have a coefficient in front of the squared term, first thing you want to do is think, well, can you just factor it out? And we can here because 3 goes into all 3 of these. So I'll factor out a 3. I'm thinking 3 times something is 3v squared. 3 times something is 3v. 3 times something is -36. Okay, got it down to that. And now I'm going to factor the remaining trinomial with a diamond problem, just like I did on the previous problem. So that coefficient here is 1 and -12 on bottom. Okay, so I'm thinking ways to multiply to get 12. You don't necessarily have to write them all out. Okay, I know one of these is going to have to be positive, one will be negative, but I don't want to write out both versions here. This is kind of what I'm thinking through, ways to multiply to get 12. And I need to somehow get a 1 out of those. Well, the 3 and the 4 is promising. If the 3 is negative and the 4 is positive, then I'm in business here. And so that's what goes in the back of these parentheses. And you can have these factors in any order, but make sure that the 3 here is negative and the 4 is positive. You can't have a -4 and a +3 because that would give you a -1 up there instead of a +1. Okay. All right, next one. This 2, I can't factor out the 2 here, and there's a number of ways you can do this. I'm going to do this with a modified diamond problem. So I'm going to take this number. Since I can't factor it out, I'm just going to multiply it by the constant at the end there. So 2 times 3 would be 6. Okay. Now I'm going to factor this trinomial with a diamond problem. Okay, so I'm thinking multiplying to get 6. 1 and 6 is kind of promising, but they'd have to either both be positive or both be negative, and that can't give me a -5. So I'm going to have to use a 2 and a 3. So I'm 2 and a 3. No, sorry, negative. Just it's early in the morning, and I was blanking out for a second. -2 and -3 is my winning combo there. Okay, so this is n-2 and n-3. That is not my final answer, because if I multiply this back together, I'll get this trinomial, not that one. Okay, so I do this little arrow to show I changed the problem. Now I've got to change my answer. And the way I'm going to do that is I'm just going to divide the number parts by the constants by 2. I'm dividing by 2 because in the beginning I multiplied by 2. So I'm taking these parts and dividing them by 2. Okay? So 2 over 2 is 1. So this first part just becomes n-1. Okay? Over here, 3/2, I can't reduce that. So if you get a fraction that you can't reduce, take the denominator and pull it out in front of the n, like so. And then the 3 will fall to the ground. And there is my solution. And again, you could try multiplying it back together. It should work. Okay. All right. Moving on. What type of transformation from the parent graph does the 3 in the following equation represent? So it's going to be a stretch or a compression when I've got a coefficient in front of the x or in front of the parentheses. So first thing I like to do is think if this is going to make my parabola, this would be a parabola, if it's going to make it wider or narrower. Okay, so this one's going to make it narrower because it's a number more than 1. Y equals 2x squared would be narrower than y equals x squared. If I had a 1/2 or a 1/3 or something like that, it would make it wider. So this one's getting narrower. Okay, so I'm just going to write that down. Now, that's not a technical term, but it still helps me figure this out. The next thing I'm going to decide is if this is a horizontal or a vertical change. So this one, since the 3 is inside the parentheses, the placement of that coefficient is what's going to determine this. Since it's inside the parentheses, it's multiplying the x directly. It's attached to the x, which means that the way I think of that, the x-axis is the horizontal axis. So that reminds me, okay, this is going to be a horizontal change. Okay? So now I still need to figure out if this is a stretch or compression. What I'm going to do is put these two things together. So if you just draw I'm just going to draw a generic parabola here, and I'll put the vertex here, and I'll put 2 other points like this. And I'm thinking, okay, I've got a horizontal change. That means that my vertex is going to stay put, but these 2 points can only move left or right. And I want to get a narrower parabola by moving those only left or right. If I move them out like this, it would be wider, right? So I want to move them in. Okay, something, I don't know, like this. And that would give me a narrower looking parabola. So then stretch or compression, well, I'm compressing it because it's squeezing it together, right? Stretching would be pulling it outwards like that, but I'd have to do a horizontal compression, and now I know that this is, a horizontal compression. So the wider or narrower thing just helps me figure out if it's a stretch or compression once I know if it's a horizontal or vertical change. Okay. All right, next up, we're going to reflect over the x-axis. So going over the x-axis, it's kind of like changing the value of the y, changing the sign of the y. So we're going to achieve that like so. All right. And this problem doesn't ask for a reflection over the y-axis, but let's cover that really quickly. If I was going over the y-axis, I'd just be changing the sign of the input. Okay, so this is a subtle difference, but it's a big difference. It's an important difference. So it's either taking the opposite of the whole function or just changing the sign of the input. So this is this version, okay? So I'm writing g of x, that's going to be my new function. And what I'm going to do is I'm going to take the opposite of the whole function. A lot of times I'll see people just do the opposite of that first term. But you know, all of this is f of x. So I'm taking the opposite of that whole quantity, which means I'm going to have to distribute the negative here. Okay? So the common wrong answer that I see is negative 5x squared minus 7. But it's actually going to be negative 5x squared plus 7 when you write it without parentheses like that. Okay. All right, next up, in which direction does the parabola open? Well, that's determined by the leading coefficient. So the leading coefficient is the coefficient in front of the x squared. If it's positive, it's going to open up. If it's negative, it's going to open down. So it's going to open downward. Okay. Okay, on to the next page. Now we're going to find the y-intercept of a quadratic equation. So to find the y-intercept, you can just plug in 0 for x. So we've got 2 spots to plug in a 0 here. And so, hey, both the parts, 5 times 0 is going to be 0, 17 times 0 is 0. So all that's left is the 27. That is going to be your y-intercept. Okay, or if you wrote this as an ordered pair, it's fine to just write it's 27, but as an ordered pair, it's going to, the parabola would cross the y-axis at 0, 27. Okay, a quick way to do this, if this is in standard form, if you have something x squared plus something x plus something else, this c is going to just be the y-intercept because those 2 x terms will just drop out. But just be careful with that because if it's in vertex form or another form, it's not going to quite work like that. But yeah, in this format, it's just the c. Okay? If you want the x-intercept, we're going to have to plug in 0 for y. So I'm going to do this first, and then I'm thinking, okay, I need to solve this equation for x. So I've got I'm going to try to factor this. That's going to be the easiest way to solve this. If it's not factorable, I could always use quadratic formula, or I could complete the square. But this one I'm pretty sure is factorable. So I'm going to set it up like that. Let's do a little diamond problem. So I'm looking for two numbers that add to 3, the same two numbers multiply to negative 18. So 1 and 18 is no good, 2 and 9 is no good, but I can do something with a 3 and a 6. If the 3 is negative and the 6 is positive, that's my winning combo. Okay, and the mistake I sometimes see is people just say, oh, that's what x equals, negative 3 or positive 6. The solution to the diamond problem isn't the solution to the whole problem here. It's just getting me to factor, helping me factor. But now I've got to use zero product property. So these two things multiply together equals 0, so one of them has to equal 0. Either x minus 3 equals 0 or x plus 6 equals 0. And that means x would equal 3 or x would equal negative 6. This has two x-intercepts, which makes sense for a parabola. It can definitely cross the x-axis twice, right? Okay, the axis of symmetry, just a reminder of what that actually is. If you have a parabola, the axis of symmetry is the line that goes right down the middle. That's going to cut the parabola in half, okay? Okay, so let's find the equation of this line. I know it's going to be x equals something because that's what a vertical line is, right? So my final answer should be not just be a number, it should be x equals some number, okay? So let's find that number. There's a little formula for the axis of symmetry. X equals negative b over 2a, all right? So here, this is a, this is b, and this is c. So if you're in standard form like I am here, there's my a, b, and c, and I just plug in the a and b into this formula. And simplify. So that's going to give me negative 12 over negative 4. Hey, a negative over a negative is positive. So yeah, the answer that's almost right that I get a lot would people would just say 3. It's not 3. 3 is just a number. X equals 3 is a vertical line, the equation for a vertical line. So it should be x equals 3. Okay. All right. Next up, let's find the vertex. So the vertex is going to be, we're going to first find the axis of symmetry because the vertex is always going to be on the axis of symmetry. So if I can find what the equation of this line is, which I can using this formula, then I'll have the x coordinate of the vertex. So that's my strategy. So let's start x equals negative b over 2a. So let's see, b is 12, a is 3. Okay, so x equals negative 2. So now I know on my, that's my, I know this is going to be negative 2 something, right? I just need to figure out what the something is. So what I can do now is find the y that goes with this. So if x equals negative 2, let's find the y that goes with it. I go back to the original equation, and I'm plugging in negative 2 for x. Okay, let's see. I've got 12 minus 24 would be negative 12 minus another 1, negative 13. So when x equals negative 2, y equals negative 13. And that means my vertex is going to be the point negative 2, negative 13. Okay, so find the axis of symmetry, then plug that x value into the equation to find the y that goes with it. Okay, now we've got an equation. This is still going to be a quadratic equation. It's still going to be a parabola, but it's in a different format, okay? So if this is what I call the y equals x squared. So it's a y equals, and then it's a positive x squared, right? I don't have a negative in front of the fraction or in front of the x. So that tells me that this is going to open up, okay? That doesn't really, this problem doesn't ask me that, but I just wanted to cover it quickly, okay? And the kind of generic form of this equation is going to look like this. Okay, the h and the k is going to give you the vertex. So the vertex would be negative 5, negative 9. But then the distance from the vertex to the focus. So the focus is going to be somewhere inside of the parabola, right? And the directrix is going to be somewhere outside, somewhere like that. And the p-value is the distance from the vertex to the focus, or from the vertex to the directrix, okay? So you can find the p-value using just this piece. So set 1 over 4p equal to whatever is in front of the parentheses there. So in this particular problem, I'm writing 1 over 44 is going to equal 1 over 4p, and then I cross multiply. So 4p is going to equal 44. Those cross products should be equal, or are equal, and then divide by 4, and the p-value then is 11. So that's that distance here, or the distance here. Okay. Okay, next up we're going to write an equation like this from a graph. Okay, so I'm going to still be using this same formula on this next problem. Okay, because I can see, okay, a focus vertex form is what I call this format. And I can see this one opens up, right? Just like that last one did. I know that, so then it has to be a y equals and then a positive x squared. So I'm just going to recopy this formula here. I'm going to be plugging into this. And looking at this, I think this should have the, I'm going to have to add this to the, it should have either the focus or the vertex in the drawing. So I'm just going to add this in, and I'll add it in on the worksheet as well. So let's put I don't know where the focus and directrix were supposed to go, but let's just put the directrix right there. And so since that's 2 units, I'll put the focus right here at the top, and that should be right above the vertex. We need either the focus or the directrix in the picture, otherwise we wouldn't be able to find the p-value. Okay, but let's start with the vertex. So this is going to be the point 26 here, that vertex. Okay, so that's the h and the k. All right, so then I know I'm just going to leave that part alone for now, but got x minus 2 squared plus 6. Okay. So the next step is the p-value, and hey, the p-value is just this. So p is going to be 2, or you could do it down here. Okay? So then I'm going to plug 2 in right here. And then I'll just simplify that into 8. Let me check my answer sheet to see what. Okay. So I got to fix my answer sheet then too, because I just guessed where the focus and directrix were going to be. All right, so here we go. Okay, next problem. And you could mess around with this. You could FOIL this and then distribute the 1/8 and put it in standard form. But I'm leaving this in focus vertex form, so in this format. Okay, next up, I can figure out if this is going to be quadratic or linear or neither of those by doing a little test. And I wish I would have left more space, so I'm going to recopy this table out here so that I can explain this a little better. So first off, these x's, you can see these are evenly spaced, like 1, 2, 3, 4, 5. I'm adding 1 unit to get from one x to the next x. But it could be counting by 2's, and then this test will still work as well. Okay, and for the y's, let's see, I've got 2, 4, 9, 17, 28. Okay, so what I'm going to do is look at the differences. So the first differences are what I would add or subtract to get from one y value to the next. Your x's have to be evenly spaced to do this, but they are here, so I'm good. So looking, okay, 2 plus something is 4, that would be 2. I have to add 5 to get from 4 to 9. I had to add 8 to get from 9 to 17. And I would add 11. Okay, so these are my first differences, and they're not the same. I'm not getting the same number out every time. Okay, so if these were all the same, say I was adding 3 on every one of these, then it would be linear, but it's not linear, so I can cross that off the list. Okay, now I'm going to look at the second differences, and if the second differences come out the same, that's the differences from one first difference to the next first difference. If these come out the same, which they do, these are my second differences. And that means this is going to be a second degree equation that fits this data. Okay, and a second degree equation is a quadratic equation. So this one is going to be quadratic. Okay. Okay, next up we've got x-intercept form. An x-intercept form, they give us the equation right here. Okay. So what I'm going to do with this is I'm going to put in my two. I'm going to attempt to find the a value. And what I'm going to do is use these two intercepts. So this is going to work nicely when I have the x-intercepts, which I do there, right? This is going to be, these are both on the x-axis, so that's where my parabola is going to cross the x-axis, okay? So this is going to give me the, this is, one of my x-intercepts is -5, so that's going to be one of, it doesn't really matter which one, but that's going to be either p or q. So let's say that p is -5, okay? And then q could be 3. And those are interchangeable. But, okay, so let's start plugging stuff into this then. So I've got x minus -5. Well, hey, that's a double negative, so let's write it like that, right? And x minus 3. Okay? Because if y was 0, then I know x would equal -5 or x would equal +3. And that's how I'd find the x-intercept. Okay? So I'm looking good so far. I just need to find the a value. And that's where this other point is going to come in. So what I'm going to do is use this xy pair. I'll plug the x and y into this. So I'm going to plug in 18 for y. And I'm going to plug in 4 for x. Okay, and now I should be able to solve for, oh, and I've got 2 places to plug in the x value there. Now I should be able to solve for a, because that's the only variable left. Okay, so let's see, 18. This is going to be 9 in here, and this is going to be 1. So hey, 18 is going to equal 9a. Divide by 9, and then a would equal 2. Okay, so now I can go. Getting off screen there. Now I can go back to here. I had everything but the a. Well, now I got the a. And there we go. Okay. Okay, one more page. Let's get to it. All right, got some word problems here. We've got a word problem really split into 2 parts. We've got the path of a baseball modeled by this equation. T is going to be the time. H is going to be the height. H is the height in terms of time. Okay. Yeah, time in seconds, height in feet. When will the baseball reach its maximum height? So let's just draw a little picture here. If here's the ground, you hit the baseball, it's going to do something like that. So hey, a parabola, right? And we're interested in the top of the parabola, which is going to be the vertex. Okay. So t is taking the place of x here. So t is going to be my input value. And then the height is going to be, that's taking the place of the y, right? So let's see. When will the ball reach its maximum height? So when, that's going to be the time, right? The time that it reaches its maximum height. What is the ball's maximum height? Well, that's its height and speed. So a big part of this that people get wrong often is just solving for the wrong variable. So you got to interpret what they're asking for on both of these. Okay. So if I'm looking for the t, that's it's just like if you're looking for the vertex. You could find the x coordinate because it's on the axis of symmetry. So I'm going to use the axis of symmetry formula, which normally would be x equals -b over 2a. Only difference here is t is kind of taking the place of x again. So t is going to equal -b over 2a here. Okay, but hey, a is -16 and b is 48. So I've got -48 over 32. Oh, and sorry, my a was -16. I was wondering why I got a negative answer there. Okay. So there we go, and that's going to come out to, that would reduce to 3/2, which is going to be 1.5. Okay, and then since this is a word problem, I need to say 1.5 what? This is time. Is this hours? Nope, this is time in seconds. It's 1.5 seconds. Okay, and then for number 16, well, I got to use my answer from number 15. Okay, so I have the x value then of the vertex. I just need the y that goes with it. Okay, so what I'm going to do is I'm going to find the height at 1.5 seconds. So I'm plugging in 1.5 for the t value and finding the h that goes with it. Okay, and then it's just PEMDAS. So I'm going to do the squaring first. Let's see, 1.5 squared is 2.25. And this is 6. 4 times 1.5. Okay. Oh, geez, I wrote 4 times t. This should have been 48 times t. I was wondering, I got a negative answer again because that should have been 48 there. Whoops. Okay, so that's not 6. I got 48 times 1.5 there, which is 72. Okay, that's more like it. So let's see, negative 16 times 2.5 is negative 36, plus 72, plus 4. So I got 36 plus 4 is going to be 40. Okay, and this is the height, and my height is going to be in feet, so let's get those units in there. Okay, so at 1.5 seconds, it'll be at a height of 40 feet, and that's the maximum height. Okay, all right. Now let's graph some parabolas, okay? So there are a number of ways you could approach a problem like this. I would find the vertex first. First off, I can see x squared is positive. I know this is going to be opening upwards. Okay, that's good to know. Same with this one. This one will also be opening upwards because got a positive x and a positive parentheses, okay? All right, so let's find the vertex. So my axis, x equals negative b over 2a again. I'll be using that a lot. My b here is 1, and my a is also 1. So this would be negative 1/2 is the axis of symmetry. Okay, well let's put that in. Okay, I'm just kind of eyeballing this here, but that's the middle of my parabola. So now I just need to find where on that line the y coordinate is. So let's plug in negative 1/2 for x, and yeah, you could do this as a decimal, but I'm just going to do it like this. It's a nice little exercise in dealing with fractions. Negative 1/2 times itself would be 1/4. Okay, let's get a common denominator for all these, so I can write these all in terms of fractions over 4. So if I multiply this by 2 over 2, I get negative 2/4. If I multiply this by 4 over 4, I get negative 8/4, right? Now I can combine them all. And this is going to be 1 minus 10, negative 9/4. And that would be negative 2 1/4. Hey, look at that. I did that without a calculator. But, yeah, you can put it in with a calculator, too. So that's where the y coordinate is. So negative 2 and 2.25, something like that. I'm just kind of eyeballing it in. I know it's going to open upwards from there, okay? And we need some more points. Easiest point to use is the y-intercept. This is going to be the y-intercept, because if you plug in 0 for x's, hey, negative 2 is right there, okay? And yeah, I know that's pretty close to the vertex, but that'll do, okay? And then I can just reflect that. It's going to have a mirror image over here. And I've got an idea of how wide this would be. You could get more points by finding the x-intercept by factoring this. If it's factorable, let's see. So factorable, the factored version of this. I'll just go ahead and do this too. Let's see. So I'd have a 2 and a negative 1. And that means x would equal negative 2, or x would equal 1. So that'll give me an even better picture. There's my x-intercepts. Okay, and now I can, got a really good idea of what this is going to look like. There we go. Got some nice points. And there we go. Okay, next up, hey, this one is in vertex form. So this would give me the x-coordinate of my vertex. I just set it equal to 0, so there we go. And then this would be the y. Okay, so my vertex is going to be 4, 1, 4, negative 1. Okay, I know it's opening upwards, and also there's no there's no coefficient in front of the parentheses or the x, so there's no stretch or compression. That means this is going to follow the pattern of the parent graph. So your standard parabola, your parent graph, if y equals x squared, you go up 1 to the right 1 and up 1 to the left 1, and then you'd go up 4 to the right 2, so 1, 2, 3, 4, 1, 2, and up 4 to the left 2. You could find the y-intercept here, which wouldn't be negative 1. You'd have to multiply that out or plug in 0 for x. But it's going to be off the graph that I have given here, so I'm just going to stick with these points that I have. Okay. One more. This one, hey, we're going to include the focus and directrix as well as the vertex here. So let's start with the vertex. Very tempting to say that the vertex is going to be negative 2, negative 3. That's wrong, because, hey, that's going to give me the y-coordinate, right? So be careful there. Set whatever the contents of the parentheses are equal to 0, and then that means that this would have to be the x. Okay, so the vertex is going to be 3, negative 2, not negative 2, 3. I don't know why I put a negative there, but I see people get those swapped a lot. Okay, so I've got the point 3, negative 2. 3, negative 2 goes right here. Okay, this one is an x equals negative y squared version, so let's think about which way that goes. The x equals 1s go left and right. If it was positive, it would go to the right. This one's negative, going to go to the left. Okay, so I know this is opening to the left. You could find some more points to get the exact width, but let's not worry about the width on this problem. I just want the vertex in the right place and opening in the right direction, and then I also want to get the focus and directrix in the right place. So in order to do that, I need to find p, the p value. Okay, so I'm going to take this and set it equal to 1 over 4p. Okay, and actually it'll work fine if you just use 1/16 instead of negative 1/16. It doesn't really matter as long as you know the focus is going to go somewhere inside the parabola. So I'm going to have to go to the left from the vertex. Okay, so if you do use the negative, assign it either to the top or bottom, doesn't matter, so that when you cross multiply, it's clear where it goes. So I've got 4p equals negative 16, divide by 4. So if you said that the p value was 4 instead of negative 4, that's totally fine with me, as long as you know where it goes on the graph. So 1, 2, 3, 4. Okay, there is my focus and my directrix. I'm going to go 4 out the other direction. 1, 2, 3. Didn't quite leave enough space there, but there it is. Okay, and then I draw a vertical line like that, and there's my directrix, and that's the end of the worksheet. See you next time.